Yeah, good evening everyone. Good evening. Good evening Tarun. Good evening. Yes, Tarun. Yeah, can we start then? Hi Sushant. Hi. I hope all the people came, so I think we can start. Yeah, this is the yesterday's class. This is the yesterday's class. So I'm starting now. Yeah, can please let me know what is the date? Let me know what is the today's date. Let me know what is the today's date. So I think yesterday 6th, today 7th. Yesterday we done until here. Algorithm definition, properties, and yeah, let me delete this. Yeah, first one is algorithm definition, next one is properties, next one steps to design algorithm, right? So yeah, something I done. Now let me start everyone. Everyone, let me start. I'm starting today's class, starting now. See this? See this, everyone. If you are preparing for GATE 2026, if you are preparing for GATE 2026, 2027, new batch is started. New batch is started. You can happily join. Go to exampreptool.com. From there, you can join for GATE CSE or GATE DA. You can join. So, right? So, DSA course for placements also there. Right? So, that one also you can join if you want. So, this is the code you can use. You will get the maximum discount. You apply this code, you will get the maximum discount. Right? So, this one, if you join in this one, 6 to 8 months, syllabus will be completed for new batch. 6 to 8 months, right? Syllabus will be completed. Remaining months you can do practice. Yeah. Let's start the today's class. I'm writing the date. 7th 11 2014 2024. Deepanshu Rastoy. Hi Deepanshu, good evening. Deepanshu, good evening Deepanshu. Good evening everyone. Good evening everyone. So let's start now. Good evening everyone. Let's start now. So 07/11/2024. Okay, fine. Now, if you go to the yesterday's class, see this one. If you go to the yesterday's class, steps to design algorithm. If you want to design algorithm, there are some steps are there. Yesterday we are already discussed. Can you see? I'm writing those steps once again. First step is going to be, right, problem definition. First step is going to be problem definition. Second step is going to be, first one is problem definition. Second one is going to be design algorithm, means selecting the template. Remember, you no need to design algorithm from the scratch. Already templates are available. You can select which is more suitable to your problem. Right? After selecting the template, to fill small gaps, draw flowchart and identify what missing. Right? Then after drawing the flowchart, then start testing. Then start testing. Right? So suppose if something is wrong while testing, you got to know something is wrong. So go to the template, do little change. Accordingly, flowchart will change. Accordingly, right? This story will repeat until there are no more gaps. In the template, maybe few gaps are there because it is a standard one. Template is a standard one. This is that is belongs to generic to most of the problems. To your problem, which is more suitable, please fill the gaps by drawing the flowchart. By testing, you got to know where missing. So please fill it. So continue until everything is okay. Now fifth step is going to be, right, because of now almost algorithm is ready. Program is not ready. Algorithm is ready. So when you say second step is over, algorithm almost 80% is over. Right? Whenever second step, third step, fourth step is over, algorithm 100% is available. Second step is over means almost 80% is available. Right? So second, third, fourth completed means approximately 100% is algorithm available. Algorithm only available, not program. Now on that algorithm means logic. Just verify that logic is okay or not. Means is it up to the mark or not? Means find out time complexity, find out space complexity, which is nothing but analysis. Right? So just analyze the algorithm. So afterwards, sixth one, if at all everything is okay, after analysis, you got to know that this algorithm is good. Then only those algorithms which are good, for them you can go for, right, implementation, which is also called coding. So this is the thing what we discussed in the yesterday's class. Problem definition. Afterwards, right, In the available templates, which template is more suitable to your problem, you select. Afterwards, draw flowchart, then do testing. If anything is missing, again go to the design algorithm, means do 1 or 2 modifications. Again draw flowchart, continue. When 2, 3, 4 is completed successfully, means you have algorithm, not program, you have algorithm. Now verify your algorithm, means your logic is good logic or bad logic, verify. Means if it is taking less time, good logic. If it is taking more time, bad logic. So if logic is everything perfect, then go for the coding. Right? Implementation is the last part. But remember, everywhere testing is there. See, problem definition also you can do testing. After problem definition is over, total, right, there is a one team which will check every possibility covered or not. Right? There is a one team which will verify problem definition is everything okay or not. Right? Like that, everywhere there is a testing. Right? My required things only I return. Okay, fine. These are the steps to write the algorithm. Now some people are asking, okay, fine, sir. This is what we discussed in the last class. Then why you return once again? Remember everyone. As a computer science student, so from the neighbors are keep on crying. Yeah, once again come back. As a computer science student, as a algorithmic person, your goal is not all the things. Your goal is designing a algorithm, right? Analyzing a algorithm, designing a algorithm, analyzing a algorithm, right? These are the two primary things. As a computer science person, your major goal is not all the things. Major two goals are designing a algorithm, analyzing a algorithm. Algorithm, design and analysis. So algorithm, design and analysis, ADA. Or people used to say AAD. Or people used to say DAA. So our concentration is second step and fifth step. Remaining all also we can do, but these are the primary things. As a computer science student, your goal is how to design an algorithm, means learning all possible templates. And one more, how to analyze the algorithms. These are the two major things, right? So you may say that, sir, what about coding? That is also important. But if I want to say two major things, right? Second one and fifth one. Two major things are second one and fifth one. If at all three major things, second one, fifth one, sixth one also. However, there is no standard steps. I cannot say everyone will follow 6 steps only. Some people maybe follow 5 steps. Some people will follow 10 steps. But indirectly, directly, major things are designing a algorithm, analyzing a algorithm. That there is an algorithm subject also called as ADA or AAD, algorithm analysis and design, or design and analysis of algorithms. Right? So this is our concentration. This is our goal. If at all everything is okay, please comment in the comment section. Everything fine, sir. We can move to the next one. If at all everything is okay, please comment in the comment section. Sir, everything is fine, sir. Right? We will move to the next one. Please go ahead. Yesterday we done. So once again I explain, because I want to say that. Right? I want to say that algorithm design, algorithm analysis, these are the two major things which we are interested. We are not interested other things. Other things also we can do, but major things are these two people. Our concentration in this subject. Second part, fifth part. Second part is we have to know how many templates are there, which is also called designing technique. How many templates are there? Next one, right? So after got to know all the templates, right? Next one is going to be how to analyze algorithm. Means how to find out time complexity, space complexity. We have to discuss that. So within few minutes we are going to that particular area, right? So I hope everyone is comfortable. Let's move to next. Yeah. Now concentrate here. Concentrate everyone. Concentrate everyone. Today's class, our target is analyzing algorithm. Analysis. Actually, our goal is a design and analysis. Now, first I am going to analysis. So today's class is, in my opinion, right? Actually, today's class is, in my opinion, started just now. Today's class, in my opinion, just started now. Concentrate. Analysis. Right, analysis. So I'm just going one by one. What is the meaning of analysis? Finding time complexity, space complexity. So you can write that. What is the meaning of analysis? Right, I'm explaining. If any problem having, if any problem is having more than one algorithm, if any problem is having more than one algorithm, then better algorithm decided by analysis. If any problem is having more than one algorithm, then better algorithm decided by analysis. So try to understand. Purpose of analysis is, if any problem having multiple algorithms, if any problem is having multiple algorithms, better algorithm decided by analysis. That is the purpose of, right, analysis. Better algorithm decided by analysis based on two parameters. One, CPU time. Two, one is CPU time, another one is main memory. Main memory. How much main memory it is taking? Main memory. Based on two factor. How much CPU time it is taking? How much main memory it is taking? How much CPU time it is taking? That is called time complexity. That is called time complexity. This is called space complexity. If any problem is having more than one algorithm, then better algorithm decided by analysis based on two parameters. CPU time, that is called time complexity. Main memory, which is called space complexity. Right? Yeah. Anyone having any doubt? So remember, your concentration should be analysis. In algorithm, first chapter is analysis. In algorithm, first chapter is analysis. So until now, some introduction is done. Right? In algorithm, first chapter is analysis. If any problem is having more than one algorithm, then better algorithm decided by analysis based on two parameters, CPU time and main memory. Because whenever a program is running, it will use the CPU. It will store data in the main memory. So whenever a program is running, how much CPU time it is taking, how much main memory it is using, that is called time complexity, space complexity. So remember, for any algorithm, time complexity is less, then it is the best one. Suppose a problem having 5 solutions, out of all of them, which solution will take less time? That means that is called less time complexity. That is the better algorithm. Right? You only say to do a particular task. To do a particular task, let us assume that we have 5 applications are available in the Play Store. To do one task in Play Store, we have 5 applications. Assume one application is taking 5 minutes, another one taking 5 hours, another one taking 50 minutes. You know very well, right? 5 minutes one you will take. To do the same task, one person doing in 5 minutes, one more is 50 minutes, one more 500 minutes. Definitely people will go for 5 minutes only. So time complexity, space complexity, that is the reason. Right? A problem having more than one solution, better answer will be, better one will be decided by two parameters, CPU time and main memory space. Okay, I feel everyone comfortable. I feel everyone comfortable. Let's move to how to find out time complexity. Right? Time complexity. How to find out time complexity. How to find out time complexity. Right. Now see answer. See the answer. What is how to find out time complexity? Remember everyone? Remember everyone? Time complexity of any program. Time complexity of any program is equal to how much time that program compilation take. How much time that program running will take. Time complexity of any program T of P is equal to how much time that program will take for a compilation. How much time that program will take for running. So time complexity of any program is equal to compile time plus running time. This is the way how the time complexity will be calculated. Compile time plus running time. Compilation may be one time. Every program will be compiled in a lifetime only once only. But that should also be calculated. So time complexity of any program is equal to compile time of that program plus run time of that program. So next question is going to be compile time is based on compiler. Compile time is based on compiler. Compiler is a software. So remember, when you say software, it is a program. When you say software, it is a program. Remember, language of, when you say software, it is a program. So that program is written in which language, that matters. Language used to build that compiler or language of compiler. Suppose assume that software you written using faster language, then compilation time will be less. Suppose that software you build using the old language, using the slow language, compile time will be more. So what I mean to say is time complexity of any program is based on compile time plus run time. Compile time is based on the compiler, which is a software. When you say software program, right? When you say program, in which language you are writing? Suppose that language is very slow language, compile time is more. Suppose that language is very fast language, compile time is, right? Fast language means compile time very less. So remember, time complexity of your program based on compile time plus run time. Compile time is based on the compiler, which is a software, which is nothing but language of compiler matter. Language of compiler is a faster one, compile time less. Language of a compiler is slow one, compile time is more. So concentrate. Next one, running time of your program is based on, running means CPU, processor. Remember, processor is a hardware, right? So hardware. Suppose using that I think nowadays M1, M2, M3. M1, M2, M3 nowadays. Previously P1, P2, P3, P4, Pentium, right? I5, I5, I7, I9, Intel. So remember what type of processor you are using, that matters. Suppose if you use M1 and M2 processor will be faster. If you use someone using M2, someone using M3, right, processor is faster. So to run your program, which processor I am using? Suppose using that i5, i7 faster, i7, i9 faster. So remember everyone, type of hardware matter, type of processor matters. Time complexity is based on two parameter, compile time, runtime. Compile time is based on the compiler, which is a software, which is nothing but language of compiler matters. Language of compiler is faster language, then compile time is less. Language of compiler is slow language, then compile time is more. Next one, running time is based on the processor, which is the hardware. So type of processor matter. If you use the best processor, less time. If you use the worst processor, more time. So time complexity based on two parameter actually. Language of compiler, type of processor. These two things matter. These two things matter. Time complexity of any program based on language of compiler, type of processor. These two things are important. Okay, fine. Some people are asking, okay, fine, sir. Time complexity based on these two parameters. Language of compiler is what? Type of processor is what? Suppose the language of compiler is assume. Language of compiler is assume that Java programming language, Java. Or maybe you can say Python, whatever it is. Language of the compiler is Java, and the type of processor, assume that M3. M3. Then running time may be, then time complexity may be very less. Two best people if you take, then time complexity becomes very less. Two worst people if you take, suppose in the COBOL or Pascal. Language of the process, sorry, type of the processor is P1 assume, Pentium 1. COBOL language, which is the old language, type of the processor is a P1, which is the old processor, which may take more time. Time complexity of your program is more if you use the two things which are bad. Time complexity of a program is very less if you use two things which are good. So please careful. Right? I think, in my opinion, everyone is okay. Now, some people are asking, sir, that's fine now. That's fine now. Now, there is a one more small description. There is a small discussion is there. Can you concentrate that also? Small discussion. Small discussion. Analysis will be two types. Analysis will be two types. Analysis will be two types. First one is, right? First one is going to be post-theory analysis. Post-theory analysis. Second one is priori analysis. First one is post-theory analysis. Second one is priori analysis. Analysis will be two types. We are analyzing time complexity, okay. We are analyzing time complexity, okay. Right? Time complexity is based on two parameters. That is also okay. Now, analysis will be two types. Post-theory analysis and priori analysis. Right? There are two types. What is the post-theory analysis? What is the priori analysis? You can see one time. You can see one time. First point here. According to post-theory analysis, if right, see everyone. According to post-theory analysis, if I ask anyone, what is the time complexity of this program? According to post-theory analysis, if I ask what is the time complexity of a given program, what they will do is, they don't calculate the time complexity of a given program, they will postpone it. If I ask anyone what is the time complexity of this program, what they will do is, whatever I am asking, they will postpone. What is the reason? If I want to say time complexity of this program, I have to know, right? I have to know in that particular computer, in which computer you are going to run this program, right? In that computer, what is the language of the compiler? What is the type of the processor? You have to say this. You have to find those. If you find those two, then only I can say what is the time complexity of a given program. According to post-theory analysis, if anyone asks what is the time complexity of a given program, instead of giving time complexity of a given program, they will postpone it. Because to find that, we need language of compiler and type of processor. Without knowing those two, I cannot say what the time complexity of a given program. I cannot say. So that's what the post-theory analysis. It is based on. Post-theory analysis is based on. It is based on language of compiler. Language of compiler and type of processor. According to post analysis, time complexity of any program is based on language of compiler and type of processor or type of hardware. But according to priori analysis, see this one, it is independent of, language of compiler and type of hardware. So according to this analysis, if you ask any question what is the time complexity of a given program, he will give answer immediately. Type of processor is independent, but previous one is dependent. It is dependent on language of compiler and type of processor, but it is independent of language of compiler and type of processor. I hope everyone is comfortable. Okay, I'm thinking that you are absolutely fine. Can you see the second step? Sir, one is dependent, another one is independent. How, sir? How independent possible? You will get to know. According to priori analysis, it's independent of actual things. Second one is independent of actual things. Without those two, how can you find out time complexity? Second one is saying that I will find out. Second one is saying that my model is based on some other thing. My model is not based on the language of compiler and type of hardware. But first one is saying that my model is based on language of compiler and type of processor. So please careful. Okay, fine. Now, because of you are taking real things into consideration, in the first model, the advantage with the first model is you may get the exact answer. Right? Let me write now. It will give exact answer. But because of he is not taking real things into consideration, it will give approximate answer. It will give approximate answer. It will give exact answer, but it will give approximate answer. It will give exact answer, but it will give approximate answer. Okay, that is also okay. Let's see the third step. One person taking real things into consideration, advantage, exact answer you will get. One person not taking real things into consideration, it will give approximate answer. Right? Can you go to the third step? Right? That is the advantage with the first model. First model advantage is exact answer. Second model drawback is approximate answer. But if you see the third step, see this one. The drawback with the first model is right? The drawback with the first model is, try to understand everyone. The drawback with the first model is time complexity of your program based on the actual things. If the actual things are changing, time complexity will keep on changing. What is the meaning? If I run this algorithm or if I run this program in some computer C1, it will take some time. If you run the same algorithm in some other computer C2, it will take some other time, because this computer to this computer, actual things are changing. Your language of the compiler may be C language. Your language of the compiler may be Java. Here may be M1 processor. Here may be M2 processor. Right? Maybe here maybe M3 processor. Maybe Pascal language. So what I mean to say is, the problem with the first approach is one computer to another computer, time complexity keep on changing. So let me write now. It will give different answer. It will give different answer from one system to another system. One system to another system. It will give different answer from one system to another system. In one system, if you run, algorithm is same algorithm. In one system, if you run 10 minutes time. If you run in another system, maybe 50 minutes. If you run in another system, only maybe 5 minutes. Because of real things you are taking into consideration, real things will change. Automatically answer also will change. Computer to computer, some small changes are there. So your time complexity also will differ computer to computer. Because of second one is anyhow independent, second method is anyhow independent. So it will give same answer in every system. It will give same answer in every system. It will give same answer in every system because anyhow is independent. Anyhow it is independent. Anyhow it is independent. So please concentrate here. Right? Analysis. Posterior analysis, priori analysis. In the posterior analysis, the actual things you take into consideration. In the case of priori analysis, you don't take the actual things into consideration. Because if you are taking actual things into consideration, it will give exact answer, but it will give approximate answer. Because of you are taking actual things into consideration, system to system, actual things will differ. So time complexity also will be differ. It will give different answer from one system to another system. It will give same answer in every system. It will give same answer in every system. So analysis, right? Two types, priori, posterior. Name itself saying what are the posterior. If you ask what is the time complexity, you don't calculate whatever you are asking. Right? You will postpone it, you will try to calculate something else. Means the language of the compiler you want to calculate. Type of processor you want to calculate. Because without those two, this model cannot work. So that is the reason. And one more thing. Yeah, please let me know if anyone having any doubt. If anyone having any doubt, please let me know. Small doubt also there. Today's class is almost started here. Today's class is almost started from here. What is analysis? How to find out time complexity? Analysis is how many types? What is the difference between first analysis and second analysis? Let me know if anyone having doubt. Those people who are watching, please let me know your opinion. Sir, I have this doubt. Sir, I have that doubt. You ask me, I will help you. Everyone, whoever is watching, please let me know what doubt you have. If no doubt, say no doubt. If no doubt, say no doubt. Everyone. If no doubt there, say no doubt. Everyone. Everyone, please let me know if you have any doubt. Yeah, if you don't have any doubt, let's move further story. Posterior analysis and priori analysis. One is a dependent analysis, another one is independent analysis. First one is a dependent analysis. Second one is independent analysis. Okay. Now concentrate, everyone concentrate. Everyone concentrate here. Everyone concentrate. Write down now. Priori analysis. Right, we will start the priori analysis. Remember, total industry follows. Total computer science industry follows priori analysis only, not posterior analysis. There are two analyses are there. total computer science industry follows a priori analysis. Because in the priori analysis, if you observe the priori analysis, it is an independent analysis. What I mean, language of compiler doesn't matter. Next one, type of processor doesn't matter. If those two things are good, then only your program is good according to first analysis. But second analysis saying that those two things are immaterial. Language of the compiler doesn't matter. Type of processor doesn't matter. Right? So priori analysis saying that these two things are doesn't matter. You have a slow processor, then also no problem. You have a language of a compiler which is very slow, then also okay. This analysis saying that anyhow I am independent. I am independent of language of compiler, type of processor. I am independent. So right, you have a nice computer, you have a bad computer, doesn't matter according to second analysis. Some people are asking, sir, bad computer also, it is not depending on the right. Second one is not depending upon the bad computer also, good computer also. Then based on what criteria is given? Remember everyone, right? Is concentration is not good computer, not bad computer. Is concentration is good logic. Good logic is not based on the good computer, bad computer. It is based on the good logic. Right? Second model concentration is logic only. Not the good processor, not the bad processor. Good logic are not that matter. If good logic, less time. Remember, total software industry is following second model only. Good logic, then less time. Good logic means less time. So everyone from today onwards, remember. Everyone from today onwards, you remember. See this one. Everyone from today onwards, remember. You have money or you don't have money, doesn't matter. You have money, you don't have money, doesn't matter. The thing which matters is brain. In your brain, good logic is there. Then you are going to reach the destination so easily. In your brain, bad logics are there. Definitely there is no use. I'm repeating once again. Money doesn't matter. Logics only matter. Good logics only matter. Those people who are running big companies. Money is not the reason why they are running big companies. The main reason why they are running big companies is good brain. Mukesh Ambani, good brain. So if you see the Anil Ambani, Mukesh Ambani, both are having same amount of money initially. Initially, they both are having same amount of money. But one person using brain, one person not using brain. Mukesh Ambani, Anil Ambani, initially both are having same money. Same amount of money they both are having. One is using the good logic, another one using the bad logic. Mukesh Ambani used good logics. Right? Good logic. Right? Means he used the brain efficiently. But maybe Anil Ambani not used. So what I mean to say is priori analysis saying that, right, language of the compiler doesn't matter. Type of hardware doesn't matter. Right? If you write the good logic, it will take less time. Right? Good logic, if you write, it is taking less time. Then that means, right, I think that is a better algorithm. Means better algorithm. Priori analysis is based on good logic. That is the reason total software industry follows this only. Total software industry follows this only. Writing good algorithm. If you have a good logic means good algorithm. Good logic means good algorithm. Total software industry follows good logic only. Right? Everyone may be having the good computer, may not having good computer. But remember everyone, if you have a good logic, even though you have waste computer, still you can manage. Try to understand. All the startup companies normally use, right, very bad computer. All the startup companies will use initial days very bad computer. They have worst computer. Every startup company initial days will use very bad computer. But still, some startups are made wonder. Some startups made wonder how it is possible. Good logic. If I, according to the first model, if you have a supercomputer, then only you can write the good algorithm. But second model is saying that even though you have a normal computer, still you can write the better algorithm. How? Just write the better logics. Just use the brain properly, then you can write the better algorithms. That's what you want to say. First analysis saying that supercomputer required. Second analysis saying that super brain required. First analysis saying that supercomputer required. Second analysis saying that superhuman required. If human is super, it doesn't matter what processor you have. Suppose isn't that you have a supercomputer, but human is not using good logics. The human being who is using that computer is not using good logics. Even though you have faster computer, there is no use. Posterior analysis saying that supercomputer is there, I will write the super algorithm. But priori analysis saying that it doesn't matter what computer you have. If you have good logics, then you can construct the good algorithms. Total software industry follows priori analysis only. Okay, I think everyone is comfortable. Everyone is comfortable. Now I am discussing about priori analysis. Are you comfortable till here? Do you have any doubt? Do you have any doubt? To proceed further, do you have any doubt? To proceed further, do you have any doubt? Check everyone. Everyone try. So we are going to discuss now priori analysis. Priori analysis based on the logic. It is based on logic. It is based on logic. What exactly priori analysis? Within few minutes I will explain. It is based on logic. It is not based on the processor. It is not based on the language of compiler. It is based on the logic. So some people are asking, yeah, that's fine, sir. But can you say the definition? How? What way you will concentrate logic? What way you will take logic into consideration? So I am writing now. Remember, priori analysis means I am writing now. It is a determination of, this is the meaning of priori analysis. Priori analysis based on the logic. Okay, that's okay. But what is the meaning of logic, sir? See the logic? It is a determination of. It is a determination of order of magnitude. It is a determination of order of magnitude of a statement. This is the definition. It is a determination of order of magnitude of a statement. It is a determination of order of magnitude of a statement. This is the definition. It is a determination of order of magnitude of a statement. What exactly meaning? I will explain. What exactly meaning of the story? I am going to explain. Priori analysis is nothing but it is a determination of order of magnitude of a statement. Right? Fine. Perfect. So to get the clarity, can you take the first example? To get the clarity, can you take the first example? So remember, I am going to explain 30 examples. I am going to explain 30 examples. I am going to explain 30 examples. From now onwards, be careful. Time complexity finding. From now onwards, I am going to explain 30 examples. So be careful. Example 1. Example 1. Take the first example. Main x is equal to y plus z. Main x is equal to y plus z. Right. So can anyone help? This program time complexity I have to calculate. This program time complexity I have to calculate. I am calculating now. Those people who are watching, please say what is the time complexity. What you are thinking. What is the time complexity of this program? Can anyone say? Please let me know what the time complexity you are thinking. It is the first problem. I am going to explain 30 problem, which is going to be very, very important topic. Today's topic is very, very important one. Today's topic is very, very important one. Yeah, can anyone say what is the time complexity? Yeah, please give answer. What is the time complexity of this program you are thinking? Try everyone. So in my opinion, today's class is just started now. Actually, this is my goal of today's class. This is the actually my goal of today's class. Time complexity of this program is how much? Yeah, I think Sunny is saying that 1. So let me check. Let me check this one. I'm giving the answer. Everyone listen. Everyone listen. Yeah, I will follow some color. Yeah, fine. That's okay. See this one. This program contain only one statement. This program contain only one statement. Everyone try to understand. This program contain only one statement. See, whenever this program is running, this statement will execute only one time. One statement is there, it's okay. This program contain one statement. I am okay with that. Whenever you are running this program, this statement will execute only one time. This statement will execute only one time, which is known as order of magnitude. Order of magnitude means whenever a program is running, a statement will execute how many times? Order of magnitude of a statement. Order of magnitude of a statement. What is the meaning? The meaning is whenever this program is running, the statement will execute how many times? One time. So just to find out order of magnitude, so only one statement is there, find out order of magnitude. Whenever this program is running, the statement will execute one time, right? So after finding it, whatever answer you got, to that answer, you can write capital O of 1. To that particular one, you write to that particular number, whatever you got, you can write capital O of 1. You can write capital O of 1. You can write, right? You can write omega of 1 also. You can write theta of 1 also. All the three symbols you can use, but as of now, use only big O. Capital O means big O. You can use all the symbols. Anyhow, we will discuss those symbols afterwards. As of now, use only big O. Capital O is nothing but a big O. So the way of reading is big O. Big O of 1. Big O of 1. Just to find out how many statements are there. Every statement order of magnitude find out. Every statement order of magnitude find out. Okay, I think you are a little bit okay. I think you are a little bit okay. Can you go to next problem? Right, you will get in the next problem more clarity. Can you go there? Example 2. Example 2. Main, example 2, main, x is equal to y plus z, main, x is equal to y plus z, for I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. Now those people who are watching this class, please let me know, this program contain how many statements? Those people who are watching this class, please let me know, this second program contain how many statements? Please let me know. Yeah, let me give answer. Let me give answer, everyone. Everyone give the answer to me. See this? It is the first statement. Careful everyone. It is the first statement. It is the second statement. This program contain two statements. Second program contain two statements. But remember everyone, whenever this program is running, careful everyone, whenever this program is running, first statement executing one time. Whenever this program is running, first statement executing one time, but the second statement executing n times. Whenever this program is running, right, first statement executing one time, second statement executing n times. You may say that some people are asking, sir, how can you say n times, sir? Can you see this? How can you say n times, sir? Reddy, sir, how can you confirm it is a n time? Let me check. How n times? Let's see this one. This is called initialization. This is called condition checking. I is equal to 1, I less than or equal to 1, so I value is 1. 1 less than or equal to n, condition true. For every true, execute the statement. After true, increment the value. Then I value becomes 2. Now 2 less than, right, afterwards it will come here. 2 less than or equal to n, condition true. Then execute the statement. Then again I plus plus, it became 3. 3 less than or equal to n, condition true. Then again execute the statement. So let me give the number. First E will execute. Next B will execute. Afterwards C will execute. Afterwards D will execute. Afterwards again B will execute. So because of colors are not visible, so I will use another color. You may get more clarity. Yeah, now see this one. This will execute first A, next B, next C, next D. This is the way how they will execute. Can you see this one? First A, next B, next C, next D, after D, B, after B, C, after C, D, After D, B. So I think remember B, C, D keep on rotating. Remember A will be one time only. This is called for loop. This is called for loop. Loop means executing many times. So first statement will execute one time. Second statement will execute n time. First statement will execute one time. Second statement will execute n times. You may say that's how n time. So one time will execute, second time will execute, third time will execute, fourth time will execute, continue. Nth time, n less than or equal to n condition 2, that is also executed. Afterwards, I value becomes n plus 1. It is a keep on incrementing until n. After some point of time, it became n plus 1. It is also became n plus 1. N plus 1 less than or equal to n condition fail. Whenever it is fail, it will come outside. So this statement will execute n time only. This statement will execute n time only. What I mean to say is, second program contains two statements. First statement executing one time. Second statement will execute n time. This is the order of magnitude of first statement. This is the order of magnitude of second statement. So if you add both the order of magnitude, if you add that n plus 1, remember in the n plus 1, whoever is the bigger one, who is the bigger? N. Whoever bigger, you keep capital O. That is the reason it is a big O of n. In the n plus 1, whoever bigger, you take it. That is the reason it is called big O of n. So the time complexity of this program is actually n plus 1. Actually n plus 1, you can say big O of n also. Because priori analysis is approximate analysis. Plus 1, minus 1, don't bother. Priori analysis is approximate analysis. Plus 1, minus 1, don't bother. Actual time n plus 1. Right? Approximately, it is order of n. That is the meaning of big O. Big O notation, omega notation, theta notation. They are approximate analysis. They are approximate analysis. N plus 1, you can write big O of n. N plus 1, you can write omega of n. N plus 1, you can write theta of n. What exactly difference between big O, omega, theta? Afterwards, I will explain. As of now, just concentrate big O. Very simple. N plus 1, whoever bigger, you take. Just keep big O of n. So I think two programs we done. Time complexity finding. This is the very crucial part of algorithm subject. Algorithm subject crucial part is finding time complexity. So I think Sunny is saying that ABD, not statements. I think Sunny is a very good question. The question what you asked is very good. Within few minutes you will get more clarity. Please remember your doubt. Please remember your doubt. Within few minutes you will get more clarity. Thank you so much for asking the doubt. It's a very good doubt. Within few minutes you will get the answer. As of now, this program time complexity big O of n. Actually n plus 1. Actually n plus 1. Right? Which can be written as big O of n. Means approximately n. Forget about small numbers. Plus 1. Forget about small number. Yeah, Sunny asked one nice doubt. Sunny asked one nice doubt. I am going to explain in further problems. Now go to example 3. Go to example 3. Right, write down now. Main, example 3. Main, x is equal to y plus z. X is equal to y plus z for I is equal to 1, I less than or equal to n, I plus plus, x is equal to y plus z. Next one, for I is equal to 1, I less than or equal to n, I plus plus, for j is equal to 1, j less than or equal to n, j plus plus, x is equal to y plus z. Yeah, my suggestion to everyone, please let me know in this program how many statements. My suggestion to everyone, please let me know in this program how many statements. Please let me know in this program how many statements. Everyone try. How many statements in this program? Yeah, 3 statements. This program contains 3 statements. Excellent. Excellent, Sunny. Sunny, thank you so much. Great cooperation, Sunny. So it is a number 1 statement. It is a number 2 statement. It is a number 3 statement. Remember, some people, you may ask that, sir, how can you say it is the second statement? What about for loop? Remember, that is a supporting character. To run, listen, to run this statement, that for loop is useful. For loop is not a statement. Inside for loop, there is a statement. This is the statement. This statement to run many times. It is doing some supporting. Some support it is doing. Some support it is doing. So in the similar way, listen, in the similar way, in one house, 5 people are there. If I ask how many people are there, say 5 people. Don't count. Pillars are there, bricks are there. Don't count all of them. In this house, how many people are there? Please say 5 people are there. In one house, 5 people are there. I am asking how many people? Say 5 people. Don't say pillars 25. Don't say bricks 1 lakh. Don't say cement 25 basta. Right? Please don't say this. Iron, right? 50 kg iron. Don't say like this. So these are supporting character. So remember, right? First statement. Second statement is executing many times. For supporting purpose, one for loop is there. Third statement also executing many times. For supporting purpose, so many statements are there. Now let's run this program. Whenever you are running this program, if you observe clearly, first statement is executing 1 time. Second statement is executing n times. Third statement is executing n square time. Third statement executing n square time. So remember, this is called inner loop. These are called inner loop. Inside one for loop, one more for loop. One more for loop. They are called inner loops. Some people are asking, sir, how inner loop is running? Similar way, whatever way above one is running, same way this also. I am executing 1 time. Can you see this one? Right? Initialization, condition checking. Remember, for every condition checking, you have to come to J loop. For every condition checking, you have to come to J loop. Now see the J loop. I is equal to 1 purpose, I came inside J loop. I is equal to 1 purpose, I came inside J loop. See how the J loop is going on. J is equal to 1, condition true, execute statement, then J plus plus, then J value becomes 2, 2 less than or equal to 1. Remember, J loop is going on. 1, 2, 3, and so on, n. J loop is n time. I value 1, J is n. Whenever J loop is completed, n time, right? Then J loop is fail. Then you will go to I plus plus. Then I value becomes 2. Whenever J loop is over, then J loop is fail. Then you will go to the outer loop. Outer loop is I. So I value becomes 2. Now again J value will start from 1. That is the meaning of inner loop. Next one. Whenever J loop is over again I value becomes 3. J value becomes 1, 2, 3, and so on n. Whenever J loop is fail, I value becomes 4. J becomes once again 1, 2, 3, and so on n. So it will continue. Lastly, I value becomes n. J also becomes 1, 2, 3, and so on n. Whenever J fail, I will go to I also fail. Whenever j fail, I will go to the I became I plus 1, then I also fail. So what I mean to say is, I value 1, j loop is n time. I value 2, j loop is n time. Every time you are executing the statement. I value 3, j loop is n time. I value 4, j loop is n time. I value n, j loop is n time. Remember, n times n, totally n square. So second statement, right? Third statement executing n square time. First statement executing 1 time. Second statement executing n time. Third statement executing n square time. Total this program is executing. Total this program executing n square plus n plus 1. This is the actual time. N square plus n plus 1. This is the actual time complexity of this program. But remember, this analysis is the approximate analysis. N square n plus 1, bigger one is n square. You can write big O of n square. You can write big O of n square. The time complexity of this program is big O of n square. Whoever bigger you take. Remember, you may say that, sir, this program contains so many statements. How can you say only 3 statements? Remember that for loop is supporting character. It is a supporting. Otherwise, how can you execute one statement n times? How it is possible? Without those supporting character, how can you execute that one n time? They are supporting characters. Right? Fine. You may get more clarity. Sunny, you will get more clarity further. Sunny, you may get more clarity further. Now, time complexity of this program is order of n square. Are you comfortable or not? Please let me know. Sunny, are you comfortable or not? Please let me know. If those supporting characters are not there, how one statement will execute n time? If that supporting character is not there, how that statement will execute n square time? Are you getting? Are you getting? See this one. These supporting characters are not there. These supporting characters are not there. How you will execute n square time? This supporting character not there. How you will execute n time? Right? So supporting character. If you say this person is executing n time, if the supporting people are not there, how he can? If pillars are not there, how building will be? If building is not there, then how building is there, then only people will be there. So remember, number of people means number of people. Remaining people are supporting character. So second statement executing n time. How? With the help of for loop. Third statement executing n square times. How? With the help of 2 loops, 2 inner loops. This inner loop is n time. This inner loop is one more n time. N times n. Right? See, 1 times n, 2 times n, 2n, 3 times n, 3n, 4 times n, 4n, n times n, n square. N times n. N times n. Every time n, like that n time, n square. Finally, order of n square. So the time complexity of this program is order of n square. Remember everyone, this is the meaning of priori analysis. Priori analysis purpose is logic, right? These are the logic. Every loop is some logic is going on. Calculating the logics is called priori analysis. Priori analysis saying that a algorithm is good because of logics, not because of supercomputer. A program is right, someone is written the great program, not because of computer, because of his logics. Right? Fine. Right? I'm thinking everyone is comfortable. Right? Yeah, fine. Sunny, we will see in the next class further story. Beside how some music is going on, we will see in the next class remaining story. We will see in the next class remaining story. Those people who are serious, if you are serious about GATE examination, if you are serious about 2026 GATE exam, 2027 GATE exam, you can join happily this new batch. Whoever is serious, they can join 2026, 2027. New batch you can join, go to exam prep tool, you can join from there. Right? For placements purpose, placement course you can join. right? You can use this code, you will get the maximum discount, right? Yeah, thank you so much. See you in the next class. Thank you, Sunny. Thank you, Sunny. Thank you so much. Thanks, everyone. Thank you. Good night.